Should start out nicer, actually. I like that question. I'll start out nicer, though. Okay. Okay, folks, as I mentioned on Wednesday, what I plan to do is I plan to mix it all up. Some of the questions will be straightforward. Some of them may be more difficult. But the idea is so that you start to really be able to pick out what you're supposed to do when. So let's just start with this one that would be considered straightforward. How many moles of carbon is in 15? Let me rephrase that because that made no sense. How many moles of carbon is in 15 moles of C3H8? Propane, in other words. Okay, so we identify what we were given. We were given 15 moles of propane. We identify what we want to solve for. We want to solve for moles of carbon. The first thing I notice about this is that I am dealing with two different substances. Two different substances. Means I need a mole to mole ratio. Which will come from the formula. According to the formula, for every 1 mole of C3H8, there are 3 moles of carbon. The other is mole to mole. So I've already got moles in my conversion factor. So I'm ready to do the math. I have 15 moles of C3H8 and I want to know moles of carbon. Well, according to the formula, for every 1 mole of C3H8, there are 3 moles of carbon. The mole of C3H8 of the mole to mole ratio is placed in the denominator so that it will cancel. And I'm left with moles of carbon, which means once I multiply this out, I get 45 moles of carbon. A graduated cylinder contains 25 milliliters of water. How many centimeters cubed of water is present? I identify what I was given. I was given 25 milliliters of water. I identify what I want. I want centimeters cubed of water. So it's the same substance. So I don't have a conversion factor needed there. But the units are different. Do the terms have anything in common? Milliliters and centimeters cubed? No. So where am I going to go for my conversion factor? Top table, bottom table. Top table. Top table is when you don't have anything in common. And when you look it up in the top table, 1 centimeter cubed is equal to 1 milliliter because they are both volume units. So if I have 25 milliliters of water and I want to convert that into centimeters cubed of water, for every 1 milliliter of water, it is 1 centimeter cubed of water. So in other words, I also have 25 centimeters cubed of water. Have you ever heard of the term CC, by the way? With medicine or in the medical field, they'll say, I'm going to give them a CC. They're giving them a centimeter cubed. That's what it stands for. Okay, let's see. How many grams of C8H18 contains 3.65 times 10 to the 24 molecules of C8H18? You identify what you were given. You were given 3.65 times 10 to the 24 molecules of C8H18. And you identify what you want to solve for. I want grams of C8H18. First thing I notice is that these substances are identical. So I don't need a mole to mole ratio. You only need a mole to mole ratio if the substances are not identical. The next thing I notice is that I have molecules. When I see the term molecules, that means I'm going to be using Avogadro's number. Which 6.022 times 10 to the 23rd of anything, in this case, C8H18 molecules, is equal to 1 mole of that thing. Avogadro's number is always 6.022 of anything. 6.022 times 10 to the 23rd of anything is 1 mole. Always. The other thing I notice is I need grams. Grams indicates I'm going to need the molar mass. I have 8 carbon times 12.01. And I have 18 hydrogens times 1.008. The carbon contributes 96.08 to the overall mass, and the hydrogens contribute 18.144 to the overall mass, to give a mass of 114.224. That 114.224 is 114.224 grams of the substance is equal to 1 mole of that substance. So now that I've broken this down, I'm ready to start the calculation. I begin with the 3.65 times 10 to the 24 C8H18 molecules. My first conversion factor needs to have C8H18 molecules in it. So I'm going to use Avogadro's number. The molecules were placed in the denominator so that the unit and the substance would cancel, leaving me moles of C8H18. Now I'm going to use my other conversion factor, which is going to be the molar mass. Of that, the mole portion is going to go into the denominator with the mass portion in the numerator. The mole portion was placed in the denominator so that the unit and the substance would cancel, leaving me mass, which is what I was asked to solve for. And you get a mass of 692 grams of C8H18. Yes. 692. I want you to look over the first few problems we did and review them and ask questions. Yes.
Does your answer, like your final answer, have the mass the same significant figures as when you get first?
Okay, so 99% of the time, your answer will have the same number of significant digits as the measurement that is the lowest in the actual problem. So in other words, I don't take into account my conversion factors. other questions? Okay, so let's look at the problem I originally thought about posting and then changed my mind, or something similar to it. How many atoms of gold can be found in 14.0 ounces of gold? We identify what we've been given, which is 14 ounces of gold. We identify what we want to solve for, which is atoms of gold. First thing I notice is that both of them are the same. I'm dealing with gold, in other words. So my starting and ending material are identical, so I don't need a mole to mole ratio. But what I do notice is that I'm starting, my first unit is that of ounces. Ounces, I'm going to go to the English system. And I find that 1 ounce is equal to 28.3495 grams. Next, I see the term atoms. And anytime I have atoms, I automatically think of Avogadro's number. Because anytime I have atoms, molecules, or ions, I'm going to go to Avogadro's number. And Avogadro's number is always 6.022 times 10 to the 23rd of something, which in this case is atoms of gold, is equal to 1 mole of that something, in this case gold. Okay, well, I've used what I could to figure out possible conversion factors. So now let's get started. I have 14 ounces of gold. My first conversion factor is going to need to have ounces of gold. So the 1 ounce of gold is going to weigh 28.3495 grams of gold. The ounces of gold were placed in the denominator so that the unit and the substance canceled out, and I'm left with grams of gold. Now, I like this particular problem for a reason. First of all, once you've used a conversion factor, you can't use that conversion factor again. But the other conversion factor doesn't have grams in it. It has moles and molecules. What that means is I'm going to need a conversion factor I did not come up with to begin with. But using what I know, when I think of grams, what do I automatically think of? Molar mass. So I'm also going to need the molar mass here. The molar mass of gold is 197.0 grams of gold is equal to 1 mole of gold. I'll place the gram portion in the denominator and the mole portion in the numerator. I did so that the unit and the substance would cancel, leaving me moles. Now I can use the other conversion factor I had because I do have moles. And so 1 mole of gold is 6.022 times 10 to the 23rd gold atoms. So now I'm ready to complete this calculation. And when I do so, I get 1.2 it froze up on me. Times 10 to the 24 gold atoms. Yes.
Okay, so when we do this, do we have to break it down to like the smallest part? We have to go all the way down to. Basically, I'm asking, do we have to do all those conversions?
There's no shorter way. Each one of those, I mean, there is one conversion factor you could condense, but you're actually going to cause yourself more headache to do so. If again, folks, the key to it is I'm following through every single time. I'm paying attention to what I need and figuring out where it's located. In this one, yes, I was missing one because I didn't have a second conversion factor that had grams in it. So I had to come up with something, but you're the ones that told me what that needed to be when I have grams. Got to have the molar mass somewhere. No, about the only other way to shorten it is to do one at a time. And yes, after each of these, you could get your answer here and then do a second conversion, get an answer here, and then do a third conversion, but you're still gonna need to do all three conversions. Okay, let's see. How many carbon atoms are in 26.98 grams of carbon disulfide? Identify what you were given. 26.98 grams of carbon disulfide. Identify what you want to solve for. I want carbon atoms. Now let's break it down. First things first, carbon disulfide has a different formula than carbon. Different formulas means what? Means I need a mole to mole. And where's that mole to mole going to come from? In this case. The what? The mole to mole comes from the carbon, but more importantly, it comes from the formula. Next thing I notice is I have grams. When I have grams, means I'm going to need the molar mass. I have one carbon at 12.01. I have 2 sulfur at 32.06. The carbon contributes 12.01. The sulfur contributes 64.12. For 76.13. That is 76.13 grams of carbon disulfide is equal to 1 mole of carbon disulfide. The last thing I note is that I have atoms, and what is the conversion factor if I see the term atoms? Avogadro's number. Which is 6.022 times 10 to the 23rd of anything. In this case, carbon atoms is equal to 1 mole of carbon. now that I have all the pieces that I can discern from the question, I'm gonna start this conversion. So 26.98 grams of carbon disulfide. My first conversion factor is gonna have grams of carbon disulfide. So I'll be using the molar mass of carbon disulfide. So 76.13 grams of carbon disulfide is 1 mole of carbon disulfide. The carbon disulfide cancels out and I'm left with moles of carbon disulfide. Now I can use the mole to mole ratio from the formula. For every 1 mole of carbon disulfide, there is 1 mole of carbon. The carbon disulfide went into the denominator so that the unit and substance cancels out, leaving moles of carbon. Now I have the moles of carbon. I need to use Avogadro's number. 1 mole of carbon is going to go in the denominator with the 6.022 times 10 to the 23rd carbon atoms in the numerator. The mole of carbon was placed in the denominator so that the unit and the substance would cancel, leaving me carbon atoms. And now that I've got what I was trying to solve for, I can solve the problem. And you've got 2.134 times 10 to the 23 carbon atoms. Yes.
How can you put 76.32
Be-
grams?
okay. To answer that though, in case anybody else has that question, it's because I needed to get rid of grams. First thing I'm gonna do is an 8-pound baby needs how many grams of medicine? First thing I'm gonna do is identify what I was given, which is the 8-pound baby. The next thing I'm gonna be doing is determining what I need. I need grams of medicine. Medicine is an apothecary. So I'm gonna be using the apothecary portion of that top top conversion table. An 8-pound baby. I looked for a conversion factor that has 8 pounds or has pounds in it. And I find that there is 1 pound for 12 ounces. The pound goes in the denominator so that the unit cancels out, leaving ounces. And then I notice, oh, wait, ounces is drams. So there's 8 drams in 1 ounce. And I was asked for drams, so that means I'm ready to solve this problem. Which comes out to be 768 drams. Questions? Not in this one. Okay, folks. That gives you some examples to work from. Or some more examples to work from. We will actually be doing more examples on Monday. And then on Wednesday and Friday, we're going to start balancing chemical reactions. But we'll do some more problems on Monday that are similar in nature. I will see you Monday.